the 7-9, the second part in which we go over the work that you did yesterday. That's on page 252 and 253. So if you don't have your book, please go get your math journal so you can look at your work and correct it with me. All right, so then draw the next 3 rectangular numbers. Okay, you can see that each of the consecutive arrays, each one increases by 1 row and 1 column. 1 row and 1 column. So you can pause the video and look at those to make sure you have enough dots. Number 2, complete the list of the first 10 rectangular numbers. 2, 6, 12, 20, 30, 42, 56, 72, 90, 110. How did you get your answers? Sample answer, you could write something like this. I kept multiplying the next 2 counting numbers. I knew that 42 equals 6 times 7. So to find the next rectangular number, I multiplied 7 times 8. So in that same pattern, if I wanted to find the next number, I put it over here. You could say 8 times 9 is 72, so that would be the next. And then you do 9 times 10 and get 90, which is the next rectangular number. And then 10 times 11, which would give you 110, and that would give you the next rectangular number. Continue the following patterns. 2 is equal to 2. 2 plus 4 equals 6. 2 plus 4 plus 6 equals 12. 2 plus 4 plus 6 plus 8 equals 20. 2 plus 4 plus 6 plus 8 plus 10 equals 30. 2 plus 4 plus 6 plus 8 plus 10 plus 12 equals 42. Describe the pattern. This is a sample answer. You might have written something like this. Each rectangular number is the sum of even numbers in order starting with 2. Or something else that follows the patterns. Okay, so as you see, first you start with 2, and then you add 4 to it, and you get 6. And then for the next one, you add to the 2 and the 4, you added the 6. And then to the 2, the 4, and the 6, you added the 8. Then to those 2, 4, 6, 8, you added 10. And then to those 2, 4, 6, 8, 10, you added the 12, and you got 42. What pattern? I'm on letter C now, 3C. What pattern do you notice about the number of addends and the rectangular number? The number of addends is the same as the number of the rectangular number. For example, 30 is the 5th rectangular number and has 5 addends. So let's look at that one. 30. Is it the 5th? 1, 2, 3, 4, 5. It is the 5th number. 30 is the 5th rectangular number. And how many addends? That means what do they add together to get it? 2, 4, 6, 8, 10. That's 1, 2, 3, 4, 5. So yes, it does have 5 addends. So if I wanted to, all right, so let's go on to D. Describe a similar pattern with square numbers. Okay, on that one, it says each square number is the sum of the odd numbers in order, starting with 1. So 1 equals 1, and then 1 plus 3 equals 4, which is the next square number. And then you have 1 plus 3 plus 5 equals 9. 9 is the next square number. And then to get the next square number, you'd add all of those in order from 1 through 7 of the odds. 1, 3, 5, 7 is equal to 16. So to get the next square number, I would add up the next odd number with the other odd number. So 1 plus 3 plus 5 plus 7 plus 9 is equals 25. Or something you might have, this is one pattern you use, but you might have found another pattern. So that's the sample answer. Okay, so the next page, we are talking about triangular numbers. So let's see what it says here. Triangular numbers are numbers that are the sum of consecutive counting numbers. For example, the triangular number 3 is the sum of 1 plus 2, and the triangular number 6 is the sum of 1 plus 2 plus 3. So continue the pattern in the table below to find a connection between triangular numbers and rectangular numbers. All right, the triangular numbers are 1, 3, 6, and then 10 and 15. Model, you've got 1 dot, 3 dots, 6 dots, and then you have 10 dots, put in a triangle here, and 15 dots, put in a triangle here. Rectangular numbers, 2, 6, 12, 20, 30. And here are the arrays for those. What patterns do you notice? This is a sample answer. Each triangular number is always half of the corresponding rectangular number. For example, the fourth triangular number is 10 and the fourth rectangular number is 20. Right, okay, so letters C. Well, I guess I should say, do you notice, just to reiterate on part B, sorry. Notice that triangular number here is 10, right? And the rectangular number is 20. So the triangular number is half as much as the fourth rectangular number. And so the fifth rectangular number is 30, and the fifth triangular number is half as much as 30 at 15. Let's look at the third rectangular number, 12. 6 is also the third triangular number, and it's half as much. Okay, so that idea should help you with this. The 20th rectangular number is 420. What is the 20th triangular? Well, it's going to be half as much as 420. So here, what's half of 400? 200. What's half of 20? 10. So that would make 210. Explain how you got the answer. Sample answer, I divided 420 by 2. Okay, D. Draw an array to show the rectangular number 20. Divide the array with a line to show the connection between the rectangular and the triangular number. Okay, so this array is of 20, which is a rectangular number. And if I draw, so what they did is they slashed it in half because they made a triangle over here, which is the triangular number. Okay, so 20, which is the fourth. Why isn't it erasing? Sorry. Okay, 20 is the fourth rectangular number. They made an array, and 10 is the fourth triangular number. And I can show that here by just slicing the rectangular number in half, because the fourth triangular number is going to be half as much as the fourth rectangular number. Okay, students, and that is all right now. What I would like you to do today is to do the rest of this Google form, in which you will find the exit ticket for the lesson. Also, you need to work and complete page 251 in your math journal, and there is an answer key provided to you at the end of the Google form for this as well. All right, that's all for now. So, sorry, correct that on your own with the answer key. All right, bye for now.